Good morning, class. We are looking at exam 4 review, covering chapters 4 and 5 from section 4.4 to 5.4, 4.4 optimization problems, 4.6 antiderivatives, 5.1 to 5.3 the fundamental theorem of calculus, and 5.4 the substitution. So here's the second part. When you have a fractional format, this happens to be a rational function. The very first step is, can we simplify? And if we cannot, the denominator is a choice of u. Notice the derivative is e to the power of t, which makes du e to the power of t dt. You put the dt next to e to the power of t, and we recognize this as du over u, and the integral of that follows log. So it's natural log of u, absolute value of u plus c. Replace that, and you're done. Bear in mind, 5 plus e to the power of t happened to be a positive value, therefore you could use parentheses instead. What about this one? The very first step is to simplify if you can. Simplification means try to factor the denominator, and if it has a factor of x plus 1, it can be simplified. As far as the quadratic functions and formulas are concerned, ax squared plus bx plus c equal to 0, x is minus b plus minus the square root of b squared minus 4ac over 2a. That b squared minus 4ac is called the discriminant because it gives us a lot of information. When it's positive, has 2 roots. When it's 0, has 1 real root. And when it's less than 0, has no real solutions or 2 complex solutions, a plus minus bi. Also, when it's a perfect square, it can be factored. So when we look at this, a is 1, b is 2, c is negative 1. And if you evaluate b squared minus 4ac, you get 8. It's not a perfect square, cannot be factored. So the denominator is a choice option. That's really the bottom line. The derivative is 2x plus 2, which means 2 times x plus 1, which makes du the same thing times dx. So du is 2 times x plus 1 times dx. And now we are going to put this in the numerator, making sure that the top, everything is there except 2. And remember, whenever a number is missing, you can put the number and its reciprocal 1/2. But if it's a variable, you can't do that. And so now, again, this part looks like this one. It's a natural log, and u is replaced. We are done. Bear in mind, in this case, because the expression 5 plus e to the power of t is positive, I can go with parentheses. In this case, I can't, because this expression can be positive or negative. If you have the reciprocal of each one, for example, this one, you have to do long division or synthetic division. If you have this one, you make up 2 fractions, and you do not need to use substitution. This one is negative 5 e to the power minus t. This is plus t and a constant. And the idea is that to distinguish between the two. You want to integrate this, you notice the independent variable is theta, so this is 5 theta. Cosine, the derivative is negative, but the integral is positive, so 2 sine theta and a constant. Anytime you have exponential, the choice of u is the exponent. The derivative is 5x to the power of 4, which makes du 5x to the power of 4 dx. Move the x to the power of 4 next to dx, and you notice everything is fine except number 5 is missing. Again, in most texts, they solve for dx. Because only a number is missing, I'm going to put the number and its reciprocal, their product must be 1. And therefore, we end up with 1/5 the integral of e to the power of u du, which is the answer itself, 1/5 e to the power of u, and a constant, and u must be replaced, and we are done. What happens when sinusoidal functions are involved? Anytime the argument is something other than the independent variable x or t or theta, that's a choice of u. Its derivative is 2x, which makes du 2x dx. We move the x next to dx, and therefore we are looking at sine of u, but this is not du. What is missing? 2. So you put the 2 and 1/2. Again, the reciprocal because their product is 1. And again, we can only do that to numbers. So we get 1/2 the integral of sine u du. The derivative is positive cosine. The integral is negative, so we get negative 1/2 cosine u and a constant. Replace the u and you're done. Now, when sine and cosine are involved, the one that has the exponent is a choice of u without the exponent. Of course, the derivative of sine is cosine, which makes du cosine x dx. So this is u squared, and this thing is du. We use the power rule on this. We get 1/3 u cubed plus a constant. Replace the u with sine x, and we are done. What if cosine has the exponent? Well, like I said, anything that has the exponent, in this case, sine had the exponent, that was a choice of u. In this case, cosine does it. Therefore, cosine is a choice of u. The derivative of cosine is negative sine x, which makes du negative sine x dx. So over here, everything is fine except negative sign is missing, and negative means -1. So you can multiply and divide by -1. That means you put a negative inside next to sine x dx and negative outside. Their product is +1. And now it's using the power rule. So this is 1/21 u to the power of 21 and a constant. The negative sign remains, and u is replaced by cosine. And that's the final answer, everybody. ln x. Anytime you see ln x, that's a choice of u in the case of integration. Its derivative is 1/x, which makes du 1/x dx. There are two ways to write it. You could write 1/x dx, or you can write dx/x. Again, I want you to recognize these two are identical. Now, to make sure we don't make a mistake, we are going to rewrite this so it becomes clear. It's ln x to the second power times 1/x dx, and ln x is u. Therefore, you're looking at u squared du. Again, we are using the power rule, 1/3 u cubed plus a constant, where u can be replaced by ln x. And again, this means ln x times itself 3 times. It's not ln of x cubed, two different things. A fractional format, the first question is, can I simplify it? The answer is no. Also notice the derivative of the bottom. If you take the derivative of this one, you get this one. The derivative of this one, you get this one because it's itself times negative. So if you choose u to be the bottom, the derivative is the top, which makes du the top times dx. So we are looking at du over u. I'm going to put the dx next to the top. And that's the case of natural log. Replace it. You're done. This expression, by the way, is positive. Ln of absolute value of e to the power of x plus e to the power minus x plus c. You could use parentheses instead. Again, natural log. That's a choice of you. The derivative is 1 over x plus 1 times the derivative of the x, argument by the chain rule is 1. So simply 1 over x plus 1. Du is 1 over x plus 1 dx. We rewrite this so it becomes clear that we are dealing with u du, and that's a simple case of a power rule, 1/2 u squared. You can go back to this and the original limits, or if I plug in 0 here, I get ln 1, which happen to be 0. If I plug in 1, I get ln 2. Those are my new limits. So you plug in ln 2, you get half of ln 2 quantity squared. 0 doesn't do anything, so the final answer is 1/2 ln of 2 quantity squared. Please understand this means ln 2 times ln 2. Okay, so don't change that. And that's an exact answer. Application problem. A bacterial colony increases at a rate of R of t 2.2 e to the power 0.4 t bacteria per hour. The moment you see rate in calculus means the derivative function. If the initial population is 800, that makes it an initial value problem. Find the population after 12 hours. A couple of different ways to handle it. We're going to go look at that. And please understand, if this is the derivative, you're looking for the antiderivative, and antiderivative normally be represented with capital R of t. Therefore, we write capital R of t represents the population, and capital R prime of t, which is lowercase r of t, represents the growth rate, and R of 0 is 800, the initial value. So according to the net change theorem, the accumulated change, the amount of increase over the course of 12 hours is the integral of 0 to 12, lowercase r of t dt, because lowercase is the rate. So replace it. Remember, the exponential, the answer is itself. A differentiation, we multiply by 4. Integration, we divide by 4. So 2.2 divided by 4 means 22. Divided by 4, 11 halves, 5.5 or 5.5. You plug in the top, you plug in the bottom, and this becomes e to the power of 4.8. This becomes e to the power of 0, which is 1. Nevertheless, you have to put it into a calculator. And because we are looking at the population of bacteria, we can round it to the whole number. We get 663. The initial population was 800. Add them up. And that's the final answer for the question. Now, the second method is to find capital R of t. That means the integral of this one without the limits is this one plus a constant. So it's been done already in essence. Where R of 0 is 800, which means 800 is 5.5 e to the power of 0 plus 5. Please understand this is 1, so times 5.5. 5.5 plus what number is 800? 794.5. And so that's the function. Now, what do you have to do is very simple, plug in 12. Now, what is the advantage of that? If we want the population after 10 hours, 18 hours, 20 hours, just plug in here. And it makes it easier that way, okay? So that's the advantage of that, everybody. If you want to evaluate it at several points, that's what you do. Breathing. We can model the rate of airflow into the lungs by the function f of t equals 1/2 sine of 2 power 5 t liters per second, where t is the time in seconds. Find the total amount of air inhaled in one cycle, known as the tidal volume, if the cycle lasts 5 seconds. Here's the note. The time for inhalation is half of the cycle, 5/2 seconds. Total amount of air inhaled follows the integral of 0 to 5/2 f of t dt. In other words, we are assuming if the whole cycle takes 5 seconds, okay, in and out, okay, we are breathing in, we are breathing out, they take the same amount of time. That's the assumption. They may not be exactly true, okay? And that's why we cut the time in half, because we are just interested in inhalation, not the entirety. So with that being the case, we are going to evaluate this integral. Now, anytime the argument of sine or cosine is not the independent variable t or x or theta, that is a choice of you. So if you have any of the trigonometric functions and the argument is not just the independent variable. So if you take the derivative, you get 2 power 5, which makes du 2 power 5 dt. So we're going to rewrite this, and I'm going to put the 1/2 out. It makes no difference if this number is inside or outside this. The integral sign makes no difference whatsoever. Now I write this, and I write this one, but I put it in a parentheses because I want you to notice everything is intact except over here 2 power 5 is missing. So and 2 power 5 is a number. If I need that, I can put in 2 power 5 and then the reciprocal 5 over 2 pi. So we have to have both of them because the product of these two is 1. Now what happens is that this becomes 5 over 4 pi. This becomes sine of u. This becomes du. And the integral of sine is negative cosine. So 5 over 4 pi, negative cosine. What are the new limits? Again, you can go back to original one, sine of 2 power 5 t, and do the math. In this case, minus cosine of 2 power 5 t. But let's find the new limits, meaning If I plug in 0, obviously I get 0. If I get 5 halves, I get 2 pi over 5 times 5 halves. Everything cancel out except pi. So from 0 to pi. And to make this calculation easy, let's put the negative out. This one is -1 minus this one is +1. They give us -2. -2 times -5, 10 over 4 pi or 5 over 2 pi. This is an exact answer. However, if you want to go with the approximation, you get those numbers. This was liters per second, so this is liters. I want you to see where we get the units from. That's important. And more importantly, even this process, this functions to a certain degree is an approximation. That's why it's okay to go to the approximation, but always show your exact answer. Evaluate the integral of 0 to power 2, 1 plus cosine t. The independent variable is t. So 1 becomes t. Cosine becomes sine. Plug in power 2, you get power 2 plus sine power 2. Plug in 0, you get 0 plus sine 0. This whole thing is 0. This has no bearing. Power 2 plus sine of power 2, we should know it's 1, and this is an exact answer. You want to keep it as an exact answer. To do this, we are going to change the square root of x to x to the power 1/2. Same here. This one has exponent 1. 1 and 1/2 makes it 3 halves. And the reason we put them in this format, so it becomes ready to be handled by the power rule. So this is 5 divided by 3 halves plus 1, x to the power of 3 halves plus 1. And this one is 3 divided by 1/2 plus 1, x to the power of 1/2 plus 1, and of course, from 1 to 4. This is 5 halves. This is 2. 3 halves. This is 2. And we're going to plug in the upper limit 4 minus the lower limit 1. So we plug in. To evaluate, I hope you recognize this as 1 and 1. So this is -4. 4 to the power of 5 halves is square root of 4, which is 2 to the power of 5 is 32. 64. 4 to the power of 3 halves, this is square root of 4, which is 2. 8 plus 16, and they add up to 76 as the final answer. All right, let's look at a couple more examples. We've seen this before, and we are dealing with a polynomial here, a polynomial inside this. So 25 minus x squared is more complicated. That's a choice of you. The derivative is -2x, which makes du -2x dx. Let's move the x, and it becomes clear what we have. Everything is intact. This is the square root of u, but this is not du. -2 is missing. So if I put -2, its reciprocal -1/2 is a must. And this remains. This becomes square root of u du, and I'm not going to write the limits yet. This we've seen it many times. It's to the power of 1/2. So this remains. This uses the power rule, 1/1/2 plus 1 to the power of 1/2 plus 1. This is 3/2. This is 2/3. The product of these two is negative 1/3. And I can go back to the original u and use the original limits. Or I can plug in this one here. 3 squared is 9. 25 minus 9 is 16. I put 4 in here. 4 squared is 16. 25 minus 16 is 9. So these are the new limits, 16 to 9. Plug in and evaluate. 9 to the power of 3/2 is square root of 9. 3 cubed is 27 minus square root of 16, 4 cubed is 64. You get minus 37. The product of negative 1/3 and minus 37 is positive 37/3. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions that minimizes the amount of material used. Reminding everyone, this is a rectangular solid. Here's the volume. Here's the surface area. If all sides are equal, we call them a cube. Here's the volume. Here's the surface area, the concept of a surface area like gift wrapping. So we are going to define our variables. We're going to say x by x by h. Because the base is square, it's x by x by h. We want the dimension that minimizes the amount of material used. Okay, the amount of material used is gift wrapping. It's the wall. If you look at the front face is x times h, and all 4 walls are x times h because the base is a square. So x times h, there are 4 of them. The bottom is a square, x squared. So is the top. Normally plus 2x squared. It's open top, just 1x squared, which means s equals 4xh plus x squared. Subject to the constraint, the volume x times h, x squared h must be 32,000. This formula, because the base is a square. S has 2 variables, x and h. We're going to use v to solve for h. That means h is 32,000 divided by x squared. We plug it in, and s becomes a function of x only. So 4x times h, which is 32,000 over x squared plus x squared. Please understand the product of these two is 128,000. X goes away, this becomes x. And because we want to get it ready for the next step, we're going to bring the x up. And because x represents dimensions must be positive. This is because x is dimension. So we write it in this format so we can get to s prime. Now calculus starts. Differentiate, which is the product of these two, negative 128,000 x to the power of negative 2 plus 2x. So that's s prime. We take x to the power minus 2 down. So we get it ready to take the LCD, which is x squared. We get negative 128,000 plus 2x cubed with the over x squared. A fraction is 0 if the top is 0. So 2x cubed is 128k, x cubed is 64k. If I want to take a root, cube root of 64 is 4, 3 zeros go to 1, x equals 40, and f prime, or in this case, s prime doesn't exist. The denominator is 0, x is 0, is not part of the domain. So we have an open interval of 0 to infinity with one critical point. So local becomes absolute. But is this going to minimize or maximize? We don't know. So we use the first or the second derivative test. Second is easier. So I'm going to use this one and can find S double prime, which means the product of these two, 256,000, x to the power minus 3 plus 2. What is the second derivative test? You have to evaluate the second derivative at the critical point to see it's positive or negative. Now, when you plug in, even if you don't evaluate it, you should recognize positive plus 2 is even more positive. And that's all we want, positive or negative. Positive means concave up. Concave up means minimum because concave up looks like this. So minimum occurs when x is 40. So what is h? If I put 40, I get 40 squared here, which is 1600, divide 32,000 by it, and that gives you h. So x squared, h is 32,000. With x being 40, h must be 20, which means if x is 40, h is 20, here's the dimensions. 40 by 40 by 20. Now, what is the surface area for xh plus x squared? It was, they didn't ask. Plug in, and when the dimensions are 40 by 40 by 20, we have the minimum amount of surface that we need, and it's 4,800 square centimeters.